Good evening, dear students. In this session, we will look into solving of system of linear equations. It is a continuation of our discussion on chapter 4 of NCERT, determinants. So this chapter we are going to learn how to solve system of linear equations using method of matrices. Why is it called method of matrices? Because we use the concept the inverse of A is 1 by determinant A times adjoint matrix of A. So hence this is named the method of matrices. Okay. So let's go into the concept. There are three equations with three unknowns, and we have to present it in a form of matrix equation. Coefficients are named matrix A. The RHS numbers, values 4, 0 and 2, they are termed as matrix B, and the unknowns X, Y and Z, they will form a column matrix. So let's see how you can do it. In general, we name it as A times of X matrix equal to B, where what will be the A matrix consists of coefficients only. So writing the coefficients, put them together. So this is the coefficients. These are the coefficients written in row 1, 2 and 3. Alright. X matrix is a column matrix. The RHS numbers, the values also forms a column matrix. So as you know, going by the order, so the coefficient matrix is a 3 by 3 matrix, unknowns, it's a column matrix, order 3 by 1. So what happens? Number of rows, number of columns, number of rows in the column matrix, number of columns in the 3 by 3 coefficient matrix are equal. So after removing them, you know what is the resultant matrix order, that is a 3 by 1. And then we have to produce from the Ax equal to B, X equal to A inverse times B. Okay. So this is the matrix equation. X matrix is A inverse times B, where A inverse is evaluated as 1 by determinant of A time adjoint A. Let us evaluate first what is determinant A. So from the matrix A, okay, expanding by row 1, I can say the method you are using is expanding by row 1. So we get the first element 1 followed by its cofactor. What is the cofactor? The diagonal multiplication 1 minus of minus 3, so it is 1 plus 3. Then followed by the cofactor negative 1, so plus 1. The minor of that element is 2 times 1 minus of minus 3 into 1, so that makes plus 3. So it's 2 plus 3. And the third element 1 into, so the minor is 2 minus 1. So the values are 4 plus 5 plus 1. So determinant A is 10. Anyhow, it is not a 0. Because it is not a 0, Matrix A is non-singular matrix, and any non-singular matrix possesses a unique inverse. So we can mention it. Since determinant A is not 0, the system of equations has a unique solution. So that is the conclusion. Continue. Let us find what is adjoint A. In order to find adjoint A, we need all the cofactors in order of every element. We need to put the cofactors together to form C matrix. We'll do that first. So what are the cofactors of the respective elements with the address 1, 1, 1, 2, etc. So the cofactor capital A 1, 1 is, so it is given by the minor 1 minus of minus 3, it's 4. Let me continue here. 1, 2 for element 1, 2, cofactor begins with the negative symbol, and then it is 2 times 1 minus of minus 3, so it is 2 plus 3 with negative sign, so minus of 5. And what about the last element of first row? So 1, 3. So that is leaving the row 1 and column 3, I have 2 minus 1. The cofactor is 2 minus 1, resulting in 1. So that completes row 1. And for row 2, let us start 2, 1 element. For the 2, 1 element, the cofactor begins with a negative sign and continue to evaluate the minor. So 2, second row, column 1. The leftover elements are minus 1, 1, 1, 1. So it is minus 1 product, minus of 1 only. So it is minus 1, minus 1, and answer is 2. Continue. 2, 2 element. For 2, 2, it's simply the minor. So it is 1 across 1 into 1, and reverse across 1 into 1. So it is 1 minus 1, giving you an answer 0. What about A 2, 3 begins with negative sign. And what about the minor of 2, 3? It is 1 into 1 minus of minus 1. So it is 1 plus 1, giving answer negative 2. That completes row 2. We'll move on to 3, 1. In third row, first column, the cofactor is forward diagonal minus 1, minus 3. Product is 3 minus of 1. 3 minus of 1, giving 2. Continue to element 3, 2. Begins with negative sign. And let's go ahead with the minor of that. 1 into negative 3 minus of 1 into 2. So it is negative 3, negative 2, giving answer positive 5. Giving answer positive 5. Then the last one, 3, 3. So it is 1 and 1 across, and reverse across is minus of minus 2. 1 minus of minus 2 gives a positive 3. So that completes the evaluation of all the cofactors. And once we have evaluated all cofactors, we can put them together in a cofactor matrix. So let me prepare cofactor matrix. I usually call by name uppercase C. Let's go on writing the elements. Cofactors 4. For the next element, negative 5. And the next cofactor, positive 1. In second row, in order it is 2 followed by 0 followed by negative 2. And in row 3, 2 followed by 5 and 3 at last. So that gives us the matrix of all cofactors. Immediately we write the expression for adjoint of A, which is C transpose. C transpose. So I can immediately do the calculation for, no, it's a matter of transposing the matrix, which means writing the rows as columns and vice versa. So row 1, it becomes column 1 here, 4 minus 5 and 1, 2, 0 minus 2, I am writing in column 2, 2, 5 and 3, I am putting in column 3. So that completes the adjoint matrix. We immediately follow, what about A inverse? We know the formula, 1 by determinant A times of adjoint A. So you can write the value of determinant A with adjoint. So I am getting this answer, 1 by 10 of 4, 2, 2 in row 1, minus 5, not 5, row 2, 1 minus 2, 3 in row 3. Well, now we have come to the final stage where we are in a position to calculate the unknowns XYZ forming column matrix X. So let us substitute what we found in matrix X formula, A inverse times of B matrix. Okay, put them together, 1 by 10, 4, 2, 2 of row 1, minus 5, 0, 5, row 2, 1, minus 2 and 3, row 3. We will continue to write the matrix B, that is 4, 0, 2, containing the values of the equations given in the RHS. So now we can evaluate row 1, column 1, row 2, column 1, row 3, column 1. Then divide each answer by 10. Okay. We'll continue. So X matrix, I am holding 1 by 10 outside. Row 1, column 1, yes, let us go ahead. We get 4 times 4, 2 times 0, 2 times 2. So it is 4 times 4 plus a 0 plus 2 times 2. Is that done? Next, row 2 times column 1. Negative 20, then a 0, then 5 times 2. So negative 20 followed by 0, then 5 times 2, 10. So that gives the answer. And row 3 with column 1, that gives a positive 4 and then a 0 and then 3 times 2, which is again a 6. Let us evaluate the totals. 20, negative 10 and 10 as last element. Now let us divide every element by 10 to get X matrix. What do we mean by X matrix? Column matrix containing variables X, Y and Z. So the answers, each number divide by 10. So divide by 10. So which gives 2, negative 1 and 1 for X, Y and Z. So the X, Y, Z in order is 2, negative 1 and 1. So I have just presented in the form of a set containing elements X, Y, Z in the same order, 2, minus 1 and 1, which can be definitely verified from equation 3 here. Equation 3 says X plus Y plus Z equal to 2. Yes, we can verify. 2 plus negative 1 plus positive 1 gives 2. Or in equation 1, x minus of y, which means 2 minus of negative 1 plus 1. Yes, that gives a 4. So it's verified. So once we arrive at the final answer, you can easily verify the correctness of your solution. Not only that, do students have to wait till the final step? Do we have to wait till this final step? Not necessarily. It is possible a student can make error anywhere here. So let me explain how we can correct or check in the course of solving the problem itself. Okay, you need not come all the way till the end and then discover a mistake, and that gives you a panicky time in the examination room. So don't do that. You can stop here at cofactors. You gathered the cofactors, you prepared, let me highlight, you prepared a C matrix here. Okay, I want students to focus and carefully give your attention. So once you have discovered and gathered all the cofactor elements together, I think this is the best time you can verify. How it is done? Very simple. Go back to matrix A. Matrix A is available. Take row 1 elements, 1, negative 1, 1. I am just writing the 1, negative 1 followed by 1. What am I going to do? Very simple. Evaluate the product, cumulatively add. Cumulative addition. That is, in effect, what we have done, we are taking elements of row 1. We are taking elements of row 1 here also, which means we are evaluating determinant value of A, expanding by row 1. That's what we are doing. We find, yes, the sum is 10. I know this is equivalent to same as determinant A. Yes, so your row 1 cofactors are right. It has to be right because you have done it already here. The cofactors. Done. What about row 2? Is that going to be correct? Let us verify. Second row elements are 2, 1, minus 3. 2, 1, minus 3. I am writing just above the existing elements there. Evaluate the product and cumulatively let us add. 4, 0 and 6. Does it give you 10? Yes, it gives me a 10. So I am happy that the cofactors what I found and collected in row 2 is 100% correct. Then proceed to row 3 and consider row 3 here. 1, 1 and a 1. So I am presenting 1, 1 and 1. The same procedure. Find the product 1 into 2, 1 into 5, 1 into 3. Cumulatively add. So that gives a 10. So we have not made any mistake in finding cofactors and gathering them, forming cofactor matrix. So once this matrix is 100% correct, transpose will be 100% correct also. Next one finally, is there any other place you can make a mistake? Possibly while copying matrix B. Matrix B, there may be a mistake. Evaluation. But once your adjoint is correct, it is easy to find any fault occurring in the solution because the fault is not here till cofactor or adjoint. The fault has to lie after A inverse times of B. So fault finding is reduced to these 1 or 2 steps here. So students, you will be finding this process definitely a boon. Okay. 1 by determinant A adjoint A is a well known formula, okay, and we are evaluating the cofactors and preparing the adjoint, and at this point only students have to take a pause, stop for a while, spend about 20 seconds maximum or 25 seconds probably. That will reduce your anxiety, panic at the last step, if you do not get proper solution which satisfies all the equations given. Okay, so this method is very effective, and hopefully you are going to get the same variety of question in board examination also. I wish you all the best, and in a very similar session, let me start discussing the properties of determinants. Thank you.